But we waited till the next morning, very patiently. It's a long night. And the next morning in the ICU where he was recovering, he wanted to get started and actually start to understand what kind of signal we can measure from his brain. And maybe for folks who are not familiar with the Neuralink system, we implant the Neuralink system or the Neuralink implant in the motor cortex. So the motor cortex is responsible for representing things like motor intent. So if you imagine closing and opening your hand, that kind of signal representation would be present in the motor cortex. If you imagine moving your arm back and forth or wiggling a pinky, this sort of signal can be present in the motor cortex. So one of the ways we start to sort of map out what kind of signal do we actually have access to in any particular individual's brain is through this task called body mapping. And body mapping is where you essentially present a visual to the user and you say, hey, imagine doing this. And the visual is, a 3D hand opening and closing or index finger modulating up and down. And you ask the user to imagine that. And obviously you can't see them do this because they're paralyzed. So you can't see them actually move their arm. But while they do this task, you can record neural activity. And you can basically offline model and check, can I predict or can I detect the modulation corresponding with those different actions? And so we did that task and we realized, hey, there's actually some modulation associated with some of his hand motion, which was the first indication that, okay, we can potentially use that modulation to do useful things in the world. For example, control a computer cursor. And he started playing with it, the first time we showed him it. And we actually just took the same live view of his brain activity and put it in front of him. And we said, hey, you tell us what's going on. Mm-hmm. We're not you. You're able to imagine different things. And we know that it's modulating some of these neurons. So you figure out for us what that is actually representing. And so he played with it for a bit. He was like, I don't quite get it yet. He played for a bit longer and he said, oh, when I move this finger, I see this particular neuron start to fire more. And I said, okay, prove it. Do it again. And so he said, okay, 3, 2, 1, boom. Mm-hmm. And the minute he moved, you can see like instantaneously this neuron is firing. Single neuron, I can tell you the exact channel number if you're interested. It's stuck in my brain now forever. But that single channel firing was a beautiful indication that it was behaviorally modulated neural activity that could then be used for downstream tasks like decoding a computer cursor.
And when you say single channel, is that associated with a single electrode?
Yeah, so channel and electrode are interchangeable.
And there's 1,024 of those.
1,024, yeah.
It's incredible that works. That really, when I was learning about all this and like loading it in, it was just blowing my mind that the intention, you can visualize yourself moving the finger, that can turn into a signal. And the fact that you can then skip that step and visualize the cursor moving or have the intention of the cursor moving and that leading to a signal that can then be used to move the cursor. There is so many exciting things there to learn about the brain, about the way the brain works.